Hi there! Let's get started. This lesson is about the random forest algorithm. Random forest is a machine learning algorithm which produces an ensemble of decision trees, and this ensemble as a whole is more powerful than a single decision tree. First of all, let us understand what the bootstrap is. Bootstrapping is an algorithm which produces replicas of a dataset by doing a random sampling with replacement. This idea is essential for the random forest algorithm. Consider a dataset Z, for example with 5 objects. How does bootstrapping works? At the first step, you pick at random an object, for example, the object number 3. Then you repeat it and pick the object number 1. Then the object number 5 and so on. Then possibly you can pick again the object number 5, because at each iteration you pick an object at random and there is no correlation with the previous step. And finally, in our toy example, you pick the object number 2. After bootstrapping, you have a new data set. The size of this data set is the number of elements in the original data set, but its content, as you can see, is slightly different. Some objects may be missing, and other objects may be present several times, more than once. Okay, the next method is bagging. It is the second idea essential for understanding of the random forest algorithm. Bagging is a shorthand for bootstrap aggregation, and it is a general method for averaging predictions of other algorithms, not decision trees, but any other algorithm in general. Bagging works because it reduces the variance of the prediction. Let me explain it to you. Here is a formal definition of the bagging algorithm. You have a training data set Z, which consists of pairs xi, yi. B is a number of iterations. And you have a machine learning method M, which can be of any nature, for example, decision trees, linear regression, neural networks, support vector machine, anything. What do? You repeat capital B iterations. At each iteration you draw a bootstrap sample Z star B of size n from the training data. Before, we have already discussed the algorithm that allows to produce the bootstrapped replicas. Then you apply a machine learning method to this data set Z star B. And finally, you obtain the model. You will denote this model by fx star B. This algorithm returns an ensemble of B models. This is how training with bagging works. The next question is how to do predictions with this ensemble. In case of regression, the prediction of the whole aggregate model is just an average of all the single models f star B. And in case of classification, it is a majority vote of all the predictions. What is the majority vote? Consider an ensemble with 5 models. And if 3 models vote for the class number 1 and 2 other models vote for the class number 0, then the majority vote will be the class number 1. Surprisingly, but the bagging algorithm really works. In most of situations with any machine learning method in the core, the quality of such aggregated predictions will be better than of any single prediction. Why does bagging works? This phenomena is based on a very general principle which is called the bias-variance trade-off. This topic is out of scope of our short course, but I will explain it to you informally. You can consider the training data set to be random by itself. Why is it so? What is the training data set? In real situation, the training data set may be a user behavior in internet, for example, web browsing, using search engine, doing clicks on advertisement, and so on. Other examples of training data sets are physical measurements, for example, temperature, locations, date, time, and so on. And all these measurements are essentially stochastic. If you can repeat the same experiment in the same conditions, the measurements actually will be different because of the noise in measurements, and since user behavior is essentially stochastic and not exactly predictable. Now you understand that the training data set itself is random. In ideal situation, you should collect as much data as possible to reduce this noise component of the data set. But in fact, you cannot run the same experiment in the same situation, as it is impossible to invent a time machine. But you can do a bootstrapping. So, bootstrapping is a method for generating very similar replicas of the original data set. What happens here? If you train a machine learning model on a bootstrapped replicas and average them, then the aggregated machine learning model will be more stable. This happens because of averaging. After averaging, the noisy parts of machine learning model will vanish out, whereas stable and reliable parts will remain. The quality of the averaged model will be better than any single model. Okay, the summary of this lesson. You have learned what the Bootstrap algorithm and bagging algorithm are. Now you can improve the quality of almost any machine learning method by doing bagging. However, it might be very time-consuming for large data sets.